In science and technology, it's often appropriate to use scientific notation because the numbers involved are either very, very large or very, very small. A scientific notation is always written as a number between 1 and 10. So it always has one digit followed by a decimal place, and then 2, 1, or however many decimals are necessary to get a good rounding, and then times 10 to some power that will help us decide where the decimal point really was. Let me show you what I mean. Suppose we have 125,000. Now that's not a very big number, but it'll make our point. We can look at this and say, if we put this in scientific notation, that the decimal point, which is currently here, would have to move to here, so that the number was between 1 and 10, 1.25. And then the power of 10 would tell you how many places it moved. 1, 2, 3, 4, 5. So the way to write 125,000 in scientific notation is to write 1.25 times 10 to the 5th power. If we had a very small number, say our number was 0.00463, then again we would have to move our decimal place over so that it was here, making our number 4.63, and then times 10. Well, now how many places did we move it? We moved it 1, 2, 3 places, but if we put a 3 here, that looks like we'd move it and make it bigger. Multiplying by 1,000 would make our number bigger. We don't want to multiply it by 1,000. We want to multiply it by 1,000th. We want the decimal place to move in the other direction. So we'll use our negative exponent notation. This is about the only place in math and science where negative exponents are used routinely and not converted into positive formats. So if a number is a small, small decimal, we could write it as a scientific notation number with a negative power of 10. If it's a very large number, it'll have a positive power of 10.